Hi kids, now we'll be going with this very regular question of how to calculate error if two resistors are connected in parallel. So anyway, you know equivalent resistance will be of this form. So you'll be taking logarithm and you'll be differentiating on both sides. See, the problem here is these three are not independent of each other. Now if you see, if R1 increases, then you may feel like total resistance will increase because it is in the numerator. But what if you can see the denominator also increases, right? So basically these three are not independent of each other, so they are dependent on each other. In fact, you can see there are only two variables. So these three are dependent on each other, so you can't go with A, B and C. So I'm just going with normal method of math. So I'm taking logarithm, then I'm differentiating it, then I'm grouping all the dr. Okay, this is dr1, it is dr1. So I'm grouping all the dr1 terms together and all the dr2 terms together, right? Then I'm modifying it. See, after that you will be taking LCM, then you will be getting R2 by R1 into R1 plus R2. Then I'm just multiplying and dividing with R1, multiplying and dividing with R2, and you know R is given by R1 R2 by R1 plus R2. So I'm dividing all the three sides with R1 R2 by R1 plus R2. So basically I will be getting R square here. Here R1 R2 by R1 plus R2 will be getting cancelled. R1 R2 by R1 plus R2 will be getting cancelled. So the same equation I can write it like this. So now if you want to find the error maximum of this thing, then that is this maximum error plus this maximum error, right? Now, but the regular method is going to be like this, because you can see there are only two variables. This is the most suggested method because there are only two variables and we don't find much difficulty. So you'll be just differentiating it, you'll be cutting off the minus, and you'll be getting this thing. Then if you want to find what is the maximum error of this thing, then there is a maximum error here plus maximum error here, right? But the traditional way, no matter how the equation looks, we always have one traditional way. That's like you will be differentiating partially with respect to R1. So dou R by dou R1 will turn out to be this thing. Similarly, you will be differentiating it partially with respect to R2. So you will be getting this thing. Then by math and stuff, you can easily conclude change in R can be written as dou R by dou R1 into dr1 plus dou R by dou R2 into dr2. That is, at what rate it is changing with dr1, and for delta R1, how much is the change? At what rate it is changing with dr2, R2, and for delta R2, how much is the change? So this change plus this change will give us the overall change, right? So from here also, yeah, this thing we have calculated, this thing we have calculated. I am just multiplying and dividing with R1 square, multiplying and dividing with R2 square. Now I am bringing this thing here so that I will be getting dr by R square equals to dr1 by R1 square plus dr2 by R2 square. Again, this maximum error equals to this maximum error plus this maximum error. So no matter what is the method, we have to end up with the same result because we know the end result has to be same, right? Thank you.